Cool. Sounds like we're recording. Excellent. So, masonry, very important product. Well, very important. I wouldn't say product because there's a whole range of products that make up masonry. The guts of it is that masonry is anything that can be any separate unit that can be stuck together with mortar to include to create a wall. So that includes your bricks, concrete blocks, and stonework. Typically, there are also, people consider rammed earth to be masonry, even though technically it's not masonry. It's not separate units stuck together with mortar. But it behaves much like masonry, use the same sort of masonry fixings, etc. So, properties of clay bricks. Tests are carried out on bricks to ensure that their limits set for dimensions, tolerances, efflorescence, transverse strength, and compressive strength are adhered to. So, 10 points for anybody who can remember the dimensions of a standard brick. Anybody? 130 by 90s. Yeah. So 231, 1076. That. Yeah, very important number to remember. Well, it was really important for me. The reason that it's so important for me to remember the dimensions of brickwork is because I did so much work from photographs. So I was detailing up stuff for places in New South Wales. So the engineers document stuff over there, take lots of photographs, send it through, and it's like, oh, they haven't given me the dimensions of that, or that, or that. So I count bricks.
Is there a tolerance on that number? It's all engineering,
yeah.
So there should be a tolerance attached to it.
Yeah, well, the brick manufacturers are responsible for their tolerances on that, and yeah, they would. I don't know what the brick manufacturers would regard as their tolerances. There's a sheet put out by the New South Wales government called tolerances in building, and I'm fairly sure it would be mentioned in there, but to the exact tolerance, I don't know. But yeah, what we'd accept, because it is essentially it's a natural material. It's clay that gets fired. As it gets fired, it contracts. There would be some variation in those sizes. And also, I say, okay, standard brick 231, 1076, and that's going to be the way for this brick and this brick and this brick. But I get to this brick. It's not 231, 1076 anymore. This is an old one. That's that's the way. And yeah, and as you point out, look, they're not not going to be exactly the same size. I think we've got 2 or 3 millimeters difference. Actually, no, about 4 mil difference between those two. This side, yeah, about 2 mil difference that way. So yeah, so they're not. How's that? Not exact, but given the interplay between the size of bricks, the size of windows, etc., drafters, when they draft up a building, they draw it up as per their brickwork dimensions. So they place their windows as per the dimensions of the brickwork. Brickies will set out first brick and a last brick and a string line and work between those two. If their bricks are slightly larger or slightly smaller, that's where they creep into their perpend joints.
Because you look at 10 bricks, that's 40 mil.
Yeah.
100 bricks, 400.
Yeah, but what? And look, I probably shouldn't talk about what bricklayers do because I've never been a bricklayer and never been that involved with a bricklayer. But they've got that possibility of expanding and contracting their perpend joints, or any of the joints they do, their bed joints or their perpend joints, and they can fit the brickwork in to certain sizes. So if you're doing work, particularly from photographs and things like that, you can be fairly sure about the spacing and the location of things by the brickwork. So you can go, okay, we've got X many bricks on here. That's going to be 240 millimeters minus 10 millimeters. That's the distance there.
even if the bricks vary slightly in size.
Tests are conducted for characteristic expansion, initial rate of absorption, and water absorption properties. That, it's important. It's certainly important for clay bricks, but far more important for concrete blocks and cement and concrete bricks. The good thing about clay masonry or clay brickwork is that as the mortar dries out, the clay bricks take up a little bit of that moisture. So they've got a certain suction to them, and they're sucking that moisture out, and they expand ever so slightly. We're talking very small amounts, but that clay brickwork expands ever so slightly whilst the mortar contracts ever so slightly. So it remains fairly stable over the wall once they're laid. However, an issue, and I've seen this with concrete block work, is I went to do the final progress inspection of a house that had concrete bricks. So these were bricks, same size as your modular bricks like this, but made out of concrete. I guess they were relatively new in terms that they hadn't fully cured by the time they were used in the wall. And what was happening is there are control joints, there is the expansion and contraction joints within a wall. They had all opened up to about 30 millimeters. And your foam filler that normally sits in your expansion joints was sitting like this. And so somebody had a new house with massive gaps in the walls because the concrete blocks had shrunk, the mortar had also shrunk over a length of wall. Now you're only talking, a couple millimeters per block, but that shrinkage of a couple millimeters per block results in, that 20, 30 millimeters of contraction over the length of the wall, and that's quite a problem to deal with. I don't know how the builder ended up dealing with that. I wasn't sent back to the place. So I did the final progress inspection, said there's this issue that needs to be dealt with. So not sure what they did with that, but that's certainly not a problem I would want to be solving as a builder. Bricks have great fire resistance. Their size enables easy handling, and placement in walls can be easily adapted to small scale, large scale structures. Brick can give a pleasing appearance and texture. So there's a whole range of glazed bricks which are pretty funky architecturally. Another movement at the moment is much how do I say it? Lower bricks, so thin bricks. The use of, I don't know what size they are, possibly only about 40 millimeters tall or so. Has anybody seen any of those in brickwork? I haven't chased that up, but that's a bit of a thing at the moment as well. Certainly, bricks this size are relatively easy to lay. That's not too heavy. Laying concrete blocks, that gets a bit worse. This is a half a Besser block. A full Besser block weighs 16 kilos. So to hold 16 kilos, slap on mortar here, slap on mortar there, and put it down, that's a fair bit of, yeah. So really quick to go laying because you end up laying a lot of them as you go, but much harder on your body than these ones for laying. So bricks made from clay. So raw material is dug from pits, crushed, ground, and screened to reduce it to fine consistency. Then it is tempered with water to produce a plastic clay ready to form into shape. Leads me also to think about, there's a bit of an issue with some bits of land between, what is the area? We've got, well, sort of between in spots between North Adelaide and the port. That used to be clay pits. So it's where a lot of the clay was dug out for forming bricks, and then after that, owners of land or developers of land and so on have just pushed all sorts of rubbish into these giant holes where the clay was all dug out, filled it all over, and built houses there, and then stuff is going like this. as you got subsidence. So that's a bit of an issue we have in spots around Adelaide as well. So just another thing important to be aware of that.
The same size, like, it's an odd number. You sort of think if it was metric, it'd be 250, 100 by 75.
Yeah.
But are they different on an international setup, or?
That's a really good question. I don't know. Never really delved into it. Yeah, no, really good point.
Yeah, because you think, I just can't see that the Europeans would like that number.
Yeah. Don't know. Actually, that's a really good point. I spent a fair bit of time in the Netherlands, and over there, it's really evident about the age of a building, because you've got buildings, that were built, hundreds and hundreds of years ago, much earlier than the building work as we know it in Australia. And you can see buildings with really tiny bricks, and you go, oh yeah, that's a really old building, that's 15, blah blah blah. And then the bricks got larger and larger and larger as firing capabilities got larger. What they've ended up settling on, I don't know. But yeah, that's a really good question. Is our standard brick the same internationally? Don't know. But we do have bricks like this, which are called modular bricks. So that differs from our standard brick in size. This one is 290 long, 90 high, and 90 wide. So
it should be 300 by 100 by 100.
No, it should be 290 by 90 by 90.
Yeah.
Why should it be 290 by 90 by 90 rather than 300 by 100? Yeah, exactly. So you put 10 millimeters onto that, then you've got 300. Put 10 millimeters of mortar onto that, you've got 100. And if you're doing double brickwork, 10 millimeters of mortar on there, you've got 200. But having said that, so modular bricks were brought out, I think, in the late 70s. And you see some places with modular bricks, but they never really took off. And part of that is, I guess, because people are fairly conservative in terms of appearance, etc. These bricks look different. When they're in a wall, they look different. And they tie a place to a certain age. You see those bricks and you go, oh yeah, early 80s. So yes, those modular bricks do exist, and so those sort of dimensions work well. When you add your 10 millimeter mortar gap, it's 300 millimeters. You look at building, like the increments of building materials and the sizes of things. 300 millimeters pops up all the time. So you look at your footings, 300 millimeters wide by 600 deep, for example. 300 by 2 lots of 300. Your plasterboard sheets, 2400 by 1200. That's 4 lots of 300 by 8 lots of 300. 300 pops up all the time. 300 by 300 tiles, or 150 by 150 tiles. So 300 millimeters pops up all the time. I'll digress just slightly. I'm not sure if I put it into the Learn site for this subject. Do we? I'm not sure if the Borrow Masonry Design Guide has in there the. Oh, well there we go. Oh, it's Midland bricks. Okay. From there, maybe we've got some links. No, I won't muck around with it for too long, unless we end up having a bit of time at the end. But basically, your standard size brickwork also works in very well with your standard size windows. And if I've got time a little bit later, I can show you those two things next to each other. But if you get a brickwork dimensioning chart and a standard size door and window chart, look at them together, you'll see so many commonalities between the two. And that's no accident. And that's also why we've ended up with standard size bricks, because if somebody goes changing the standard size bricks, then you go changing the standard size windows. The whole thing about standard size windows, though, I think is something that's probably going to change in the near future in Australia, because we're starting to see companies that manufacture windows in China. They manufacture them at a very good price, and you can have whatever size you want, basically, you know, as per the glass allows. So, you know, we've got limitations on the size of glass and the weight, etc., and the transportability of windows in shipping containers, etc. But beyond those constraints, you can go, I want a window this size, and you'll find, because of because of the cost of manufacturing here in Australia, you can typically now get just whatever size window you want, cheaper than the standard windows that are just churned out.
So, cost on windows and containers.
Yeah.
Only 3 weeks ago, after our last class,
Yeah.
I was chasing down some autoclave and ended up over at the old Mitzi factory over at Lonsdale in a warehouse there, and there was a bloke that was importing knockoff feedwood.
Right. Okay.
And
yeah.
he, in the very next container, had Georgie windows, only just started in Geelong.
Yeah.
Geelong windows, straight from China.
Yeah. Yeah.
About 5 container fuls of them. Well, as you said, all made to order. And he was doing the unpacking. This bloke was doing the unpacking of the things, and he was cracking a bag because your container might have some of my windows in, and some of his windows in. So the Chinese had no idea of packing, consignments together.
Yeah.
They just went, okay, we'll put this size in this container and this size.
Yeah.
And this poor bloke was going nuts.
Oh yeah, but
the quality of them wasn't there.
Yeah,
so
right.
You would look at it like. So I was thinking, okay, maybe I can save quite a substantial amount of money. When you looked at the finish of the aluminium frame, it wasn't.
Yeah, right. Yeah, no, so from what I've seen from them, I've actually been fairly impressed. So possibly there's a lot of variance in quality.
I'd say what you see in the showroom.
Yeah.
To what I saw in those containers, it was like looking at the autoclave. I got a sample of it from the steel tools.
Yeah.
Because I was getting the builder to test it.
Yeah.
Because it's like half the price of it.
Yeah.
But it's only got 1 quarter of steel.
Right. Okay. And they supply all the engineering for that, do they?
Well, they've sent me all the compliance certificates out of the mob in Queensland.
Okay.
So.
Yeah.
Are windows actually made to a set regulation, like, or because you have a look at the windows here, they look different to buildings in the Adelaide and that sort of thing with the extrusions and everything.
Yeah.
So do architects actually design windows to their own specification?
Typically not. They don't design the extrusions because to make those billets for actually extruding that aluminium, that's something that's I imagine that's quite expensive, and it's not something you're going to go, I want this particular thing. Maybe you do if you're doing a big project, you've got plenty of money, and it's well worth doing that. That might happen, but I don't see that happening at all. You got people who manufacture those aluminium extrusions like AWS and various different other and then your window companies like Dal and Stegbar, and I can't think of any other window companies off the top of my head. they'll buy those aluminium extrusions and then make up their windows with their hardware, etc. from them. So it is very standard. But what you do get is, of course, you get different mullions used in commercial context than you do in a residential context. But the whole theme of where does residential finish and commercial start? There's no straight line there. It's all blurred. And when you're dealing with large sections of glass, etc., you may end up going for much larger framing size members.
We're on bricks.
What's that?
So we're on bricks.
Yes. Oh, yes. Sorry. Yeah. So yeah, we're talking about bricks. So common bricks 230, 110, 76. Modular bricks 290, 90, 90, and then some jumbo bricks of 390, 110, and 90. Bit of terminology in regards to your brickwork. So your arris here, that's the corner. So I don't have a tumbled arris brick in here. I'm pretty sure I don't. But so these all these bricks have got sharp arises. But there's a type of brick called a tumbled arris. Also a bit of a mid-90s thing. They did, when bricks were soft, dent them up a little bit. What's that?
Little Hampton did a lot of clay ones off.
Yeah. Yeah. So just tumbled arris break. Make them a bit rounded, etc. So this is the stretcher, and that's the perpend. So stretcher, perpend, and so perpend joints. So you mortar between here, perpend joints, bed joints underneath or on top. Half bond, or also called stretcher bond. That bond of brickwork is the most common bond of brickwork that you'll see in houses, because typically the only brickwork you're going to see in houses now is single leaf masonry. So that's where you've got just a wall that is just one layer of bricks thick. That's it. And then that's joined to a timber frame to make our brick veneer walling. Another form of masonry that you get is cavity masonry. So typically that's called double brickwork, but double brickwork technically is that, where you don't have cavity. And double brickwork shares bricks. And so we'll have bricks like this, and then we'll have bricks that go between the two leaves of that. When we have that sort of thing, then we get other types of bonds like this showing. So there we've got some stretchers, then we've got some headers, and a whole series of stretchers and headers. So that's this is our double brick wall. That's our cavity masonry. And then this one is our single leaf masonry. Oops. So, other types of masonry units, adobe or mud bricks. So not all that common in Australia, but if anybody's, been to the Middle East, South America, where else does mud brick get used? Yeah. Was that?
Sri Lanka.
That?
Yeah, it's mud bricks, and we sun dried brick.
Yeah. Yeah. So it's actually used a lot around the world. Yeah. Very common. Not so common in Australia, and it gets a little bit difficult in Australia as well because we've got insulation requirements through our walls, so it's hard to meet those requirements. But still, you see a few buildings built about the place.
How do these go? All of these go with the earthquake ratings. Like I know I've seen bricks on TV where Italy and they look completely different to what we got because of the earthquake.
Yeah, that's those really thin red bricks. In Spanish they call it papel, but I don't know what it's called in Italian or you can buy them in Australia. They do exist, but I just see them so rarely. I don't even know what they're called.
So is any of our masonry earthquake rated or?
I don't know. Don't know about the Earth. I don't think.
Geologically that unstable. I mean,
Well, no, we're not geologically that unstable.
So
At the
why-
moment, I mean, there's no, but yeah, we certainly don't have a history of it. We don't
so why
have
would
a,
they bother? I mean,
yeah,
doesn't make any sense.
yeah, we don't have councils requiring that. But also, it's not, when you're talking about earthquake resistance, you're not talking about just a material as such, but a material in context,
Yeah,
and that working as a building system.
Yeah, because the public buildings like hospitals and schools have to be built earthquake proof.
Hmm.
You know, so do they use different masonry or what?
I don't know. One thing I do know is that I studied with a fella from Colombia who told me that in Colombia what they do, because they get a lot of earthquakes there, they build with concrete corner sections with steel reinforcing in them, and then brick infill in between those concrete piers, and they have a gap between those concrete piers and the brick infill, and that has a spongy rubber layer. Is that?
Yes.
Yeah. Yeah, and you have that sort of
Yes.
yeah in Iran as well. Yeah, and I saw a lot of that sort of construction in Turkey. So is there a lot of earthquakes? Well, was it BAM in
Actually, yeah, was a band the last one, but I was 9 years old. My father was died in earthquake as well, you know.
right? Yeah, right. Yeah, yeah. And that was
When I,
in Tehran.
no, in the Gilan, in north of Iran,
Okay.
and they call the, you know, the power of the earthquake is different than other. Was 8.5. Like
Right.
that.
Yeah. Yeah. Yeah.
And he was a civil engineer as well, and he working underground, and 2 months cover the towns, you know, and they put the just black flag. They couldn't help
Yeah.
anyone.
Yeah. And that's still, even though they were designing for earthquake resistance. Yeah. Yeah. So it's very different scenario to what we have to do with.
Yeah, because that's what sort of got me is that, you know, if we're not being building planners or architects, if we move into that commercial setup and doing public buildings, and we have to design to earthquake proof, you know, it's sort of thinking, well, how do you know, why would you want to make a building earthquake proof in Adelaide for a start? And, you know, how would you do it? Because I can't, you know, when you look at the masonry that's available for earthquake areas in Europe, it doesn't look anything like ours.
Mm. Yeah. Yeah. So I guess if you're going into that specialist sort of construction, then you research around it.
And actually, I really like to see Australia look like a big island on the water, you know, on the ocean. And we don't have a mini earthquake in Australia. That's the reason maybe we don't have a mini requirement in the residential.
Yeah, the whole thing
house.
moves.
Yeah. So we don't get that differential
If
movement
we
of
have
tectonic plates.
we can feel in some things, sometimes the news say we have a earthquake a little bit in Adelaide or anywhere,
Yeah.
but not much.
No, not much. Very inconsequential.
Let's go to videotape.
So apart from our mud bricks, so rammed earth. Does everybody know what rammed earth is?
Expensive.
Does anybody not know what rammed earth is? So don't be shy.
I think I know what it is. It sort of basically goes in a mold and then just gets compressed.
Yeah. I can't bring you in any rammed earth because it ends up being existing as large walls. But that's basically what you do is you do a concrete footing and then you do some really strong steel formwork. You get soil, but the right sort of soil, not soil with a lot of humus in it, but soil which can be well compacted, and you add about 17% cement mixture as well to make it stabilised rammed earth. You put it into the formwork and then you ram it down, and you ram it really hard, and it ends up forming rammed earth. the Great Wall of China, a lot of that was built with rammed earth as well. There's, it's something that's been used for a very long time around the world. Once again, there's not a there's down at Wollonga. There's a whole area in Wollonga that's all rammed earth, and that's some really impressive stuff. Probably our most well-known rammed earth building in Adelaide is the National Wine Centre. Does anybody know the National Wine Centre?
I think it looks like
Yeah.
a boat or a wine
Yeah,
barrel.
yeah. So I'll just quickly bring up an image of it for those that don't know the building. Well,
Near Botanic Garden?
yeah. So right by Botanic Gardens. Let's see if maybe there's. Well, see this wall here. This is rammed earth, and I guess there's a beautiful architectural concept really in that how soil is so important in influencing the character of wine. So there's that strong link between wine and soil. What the architect designed in this instance was that soil from the 7 major wine regions of Australia was brought in, mixed up together, and they built that wall with the red soil from those major wine regions. So
That's a terra rossa.
yes, exactly, terra rossa, red soil. So it's a great architectural concept, but it's also a beautiful. I find a good photograph of it. What was that, Doug?
Good place to have a Friday afternoon session.
Right.
Now, is rammed earth usually an on-site process?
Oh, yeah. The thing with rammed earth is it's really poor intention. So, like, concrete is not good intention. Rammed earth is terrible intention. I would not like to try to make a rammed earth panel and then try to truck that around the place and lift it into site. I think I'd probably have a big pile of dirt on the back of the truck by the time I got to site.
It's very easy to make them.
What's that?
They're incredibly easy to make them.
Yeah.
If you wanted to go on YouTube and watch videos of making rammed earth walls, you could make a rammed earth wall up to about that high, that wide, like as a violet in a day yourself.
Yeah.
And there's not much involved, as in like getting the earth, you put a bit of cement in it, and then you just beat the shit out of it or something.
Yeah, compact it, and and compact it in certain layers. You just have to have very strong formwork. So formwork that will resist that pressure as it's being compacted.
The one thing that gets me is the actual equipment you use is just as suitable for making a concrete wall. It's like the rammed earth.
Yes, I haven't spoken to a rammed earth builder about this. I expect the formwork would be stronger. You'd have more strucking of your formwork.
It is basically the same.
It is basically the same?
I did approach a rammed earth bloke about my place to start with.
Yeah.
And got him a quote on the house.
Is it cheaper or?
Yeah. Thinking about.
Yeah.
Homes and looked at all his gear. And it basically is the same steel formwork that they used when they bought the bottom of my place.
Yeah.
But a lot stronger spacing.
Yeah.
So the steel work is pretty much the same, because the placing to stop the spread.
Yeah.
And the cost of it is like maybe 5 times the cost of doing that.
Yeah.
It's horrendous.
Yeah. So it's quite expensive and doesn't get used a great deal, but it has some beautiful results. And also rammed earth really poor in insulation, but very good in thermal mass. So it works well for a wall which is enclosed within a house. It works very poorly for a wall which is on the external of a house. So what's that?
That doesn't make sense because
Yeah, it does.
the actual thickness of it.
Yeah, okay, yeah. So structurally it makes it's fantastic for external load-bearing walls, yes. So structurally, yes. But thermally, no. Because it transmits heat really well. And if you're, yeah, let's say we build a rammed earth house up in the hills. Wintertime would be terrible. You know, we'd be heating the house all the time, and the heat just travels through the walls and is heating the atmosphere outside. It's really, really poor in insulation. Yes, we can insulate the outside of it, but then we lose that rammed earth aesthetic. We have that rammed earth aesthetic on the inside, but you'd have to insulate it, batten it out, have some corrugated sheeting or whatever you want, lightweight sheeting on the outside of it. Then I guess that works very well because you're utilising the thermal mass of it. But yeah, you do have to be aware of that with rammed earth construction, is that it's fantastic in thermal mass, but really bad in insulation. So one fantastic use of it, which is like essentially what they've done with the National Wine Centre, is use it as a spine wall. So it's a wall which in part in this building is in the centre of the building, and then elements are mounted off of that. So it's using its compressive strength to mount all this stuff off of it, but it ends up being on the inside of the building. Right. Back to these. So that's some rammed earth, some adobe or mud bricks. Straw bale. I guess essentially, yes, straw bale is a form of masonry. It is separate units which are put together, but one major difference between straw bale and, well, actually, the straw bale is, you should think of it very much like a brick veneer dwelling, but with big, fat, spongy bricks. That's pretty much how it's built. I don't know if there are any load-bearing straw bale houses in Australia. Yes, you can do load-bearing straw bale houses in Australia. You would just have a really difficult time getting it certified.
I think at the last expo, there was actually an architectural business that does straw bales. That's all they do.
Yeah, yeah. What's their name?
The Eco Arts Centre.
Yeah.
Yeah, I can't remember.
Yeah.
I still got a flyer.
Yeah, yeah. There's a few, and there's people I know out at the Food Forest out at Gawler. They run straw bale building workshops out there at their place as well.
And now they're doing I think hemp blocks as well.
Yeah.
You know, and I think that's just a bit of a gimmick because we don't grow enough hemp to make.
Yeah. Well, I think hemp is a fantastic material. Once people or once governments, legislators get over the idea of the fact that it looks the same as cannabis, which has THC in it. I think it is a fantastic material in terms of the way that the hydrocarbons are structured to make this this natural product with good tensile strength and good malleability, etc. So it's a good thing. But yes, at the moment certainly it's quite gimmicky because we can't just grow lots of hemp everywhere like we can straw. In fact, although the funny thing is, straw is a bit expensive now as well because particularly in Japan for horse racing, they've got huge requirements for straw now. And so guys I went to school with, because I'm up in the north, they're flat out these days, just producing straw. That's what they do, and exporting it all to Japan in massive, or get massive bales, compress it all, send it over there. So it's not actually an abundant thing so much anymore in Australia, just because we export so much of it. So possibly, straw bale you can see is possibly a little bit gimmicky as well. But the construction of straw bale is, you've got to have a load-bearing frame. That you can't use the straw bale as the load-bearing element. You've got to have a load-bearing frame which holds up your roof, provides your structure, and then the straw bale, that's basically a substrate through external render. So it's like
a filler.
Yeah, but it's a filler with really high, really good insulative capabilities. So it's a substrate that has excellent insulation, but fairly poor form. Typically, a lot of your straw bale built houses are a little bit artsy craftsy looking, rounded corners and so on. I have seen one straw bale built house which was rendered amazingly. It looked really good when it was done. I think they had a very good renderer working on it. So by all means, it is possible to get a very sleek look with straw bale if you got the rendering right. But I dare say it's much harder to work with than say Hebel or something as a substrate for your render. Concrete blocks. So yeah, concrete blocks go up very quickly, but they're fairly heavy. One of the fantastic things about concrete blocks is they can be core filled. So you can do a wall, and then that ends up being a formwork, and you can introduce steel rods, and then fill these cores, the concrete blocks, with concrete themselves, and produce a concrete wall with reinforcing running vertically through that concrete wall that's shared with the footings. Very handy for that. And it's used in all sorts of scenarios. Doug, probably used in your place as well as
we've gone brick, concrete brick.
Yeah.
The Rio with a 150 gap and then concrete brick again.
Right, and then that gap is getting core filled, is it? Yeah. Okay, so you needed a much larger.
We needed 350.
Yeah.
As the thing. So
But for many situations where you're producing a wall which also has to be a retaining wall, concrete blocks are fantastic for that with reinforcing introduced. Other forms masonry. So here's some very elegant stacked stone. So appears to be granite that's all being cut and stacked. Various different bonds. And we'll go through that quickly. This is only for double brickwork. So it's not for cavity masonry. It's only where you're sharing your brickwork between two leaves of brick. So stretch bond, English bond, Flemish bond. There's a whole bunch of bonds. Colonial bond, stack bond. You'll certainly encounter that sort of stuff if you travel around, particularly the Netherlands and Germany, and look at old brick architecture there. There's some amazing brickwork. In Australia, not so much. So yes, the quality of our bricks and the size of our bricks is very important, and the quality control around that. So is the production of mortar. Now, I'm not about to go out there telling a bricklayer how to mix their mortar. Probably leave the site with a blood nose if I was to do that. But technically, mortar mixers must comply with AS 3700. So AS 3700 is the Australian standard for masonry. So we have a whole host of Australian standards, as you're probably all well aware. We've got the National Construction Code, which has referenced standards. The Australian standard for masonry is AS 3700, and it defines how mortar should be, the parameters in which mortar should be made. So general purpose mortar, 1:1:6 are your ratios: cement, lime, and sand. It specifically says within that Australian standard that detergents are not to be used in the mixing of mortar. So that was a bit of a trick that some bricklayers would do to help with the plasticity of the mortar and detergents. It has been included in the Australian standard that you're not allowed to use detergents in mortar mix. Mixing is a process called batching, carried out by volume. Use gauge boxes, not by shovel. But it's up to the bricklayers, essentially, how they mix their mortar. So joints, bed joints, and perpends. So once again, a bit of a reminder. Bed joints, base and the top, perpends on the sides. Joints are formed as work progresses. So the bricklayer, trowels on the mortar and trowels on the mortar, slaps it on, trims it off, and they produce those joints as they work. The process of forming a tool joint after the work is complete is called pointing. So as the bricklayer is laying their bricks, they scrape the mortar off, all the little lumps, etc. They scrape the mortar off, and then later on they carve the mortar out nice and neat. So they don't do that when the mortar is soft, they do that when the mortar has gone off to a certain extent, still when it's malleable, but when it's firm enough to be able to get a very neat result, so not when it's wet. I think that's one pointing tool. I'll pass that around there. That's an 8mm rod for giving a coved. So special tools used to shape the mortar. Most common joints rate concave, so that tool will do a concave joint, struck and cut, pointed and beaded. So here are a few raked, well, how to say it, pointed joints there that you may see about the place. Concave, really common. Flush, it's a bit of a modern aesthetic. Raked, also really common. Deep raked, sort of 1990s, and the other ones you don't see so much. Every now and again you see some single leaf masonry walls, particularly in garages. So you might have a single leaf masonry wall in a garage. There are limitations to how high you can go with a single leaf masonry wall. It's about that stability of, of width of the wall as opposed to its height. If I keep going up, I'll end up having something which has a lot of leverage with a very thin base. So there are limitations to the height of a wall, and they're set out in AS 3700. I can't remember them off the top of my head, but what you get to overcome that are what's called engaged piers. So it's where you have a single leaf of masonry, but then you have masonry next to that. So you can also have an intersecting wall acting as an engaged pier to give that lateral support. Or do I have any? No, I don't have any images of an engaged pier. I'll quickly draw one up. If we were to look, typically you see these in garages. So a garage or an semi-enclosed carport on the edge of the house. You've got your single leaf masonry wall here, like this, and to provide lateral support to that, you have a series of brickwork there, like that. Can anybody imagine those or think of those? Maybe I'll do a Google search for an image of that. Gauge. There we go. Came up with lots of people getting engaged on the pier. That's funny. So that's your typical engaged pier there. What has to happen with that engaged pier is that either this pier of brickwork has to share bricks with this single leaf masonry wall, or has to be tied in to that masonry wall with brick ties. There's no point, well, very little point in having a pier which is unengaged, which only shares a mortar joint. Mortar is good in compression, but it's really not good in tension. It doesn't glue blocks together. And I've seen it. I've seen piers being built with that just share mortar and that have come away.
How many wires go into it?
Every 300 centres, so every 4 courses of brickwork. The other one, I'll close that one down. Stop confusing myself. So here is a brick tie. That's bonding that leaf of brickwork into the single leaf wall. Essentially, your brick veneer walls are single leaf walls as well. they don't get supported by engaged piers. What they get supported by is the timber frame in behind, and that timber frame is once again tied to our brickwork with brick ties. Every 600 centres, they're tied with brick ties, or 300 centres around door and window openings. So here we have brick ties or wall ties, so they tie back to the studs. Those ties are incredibly important because without being tied to that, this timber frame, this structural frame actually provides the structure of the house. The brick is just a cladding on the outside. It's a fairly weather resistant, long-lasting cladding, but it is just a cladding. It doesn't actually provide any structure to the building, and it's all tied in with these brick ties.
Is the actual brick wall just a decoration?
Well, no, it serves a purpose in keeping the whole frame shielded from the weather.
But the roof doesn't actually sit on it, does it?
No, the roof doesn't sit on it, no.
So, you know, it's not a structural...
It's not a structural thing, no. No, it provides next to no structure at all. If we're driving to it with a car, yes, it's the first form of defence before the car hits the wall, but that's about it. It simply just acts as a skin on the outside of the building, and a fairly weather-resistant, long-lasting skin. Although I say weather-resistant, but all brick walls have to have weep holes at the base of them, because it is just simply accepted that water gets into brick veneer walls.
You'd probably be better just describing it as a membrane, really.
Yeah.
It doesn't matter what you put on the outside. It may be decorative or it may not be. If you're going to use blue board,
Yeah.
you know, it's the same.
It's
just
covering. It's an external cladding.
So you might say that blue board might have an insulation value of 1.2 and bricks is 1.8.
Yeah. That thing of insulative value. Well, with brick veneer, it varies so much because it all depends on how the top is detailed, whether you enclose it or you don't enclose it. Some brick veneer buildings are built where you could just have air just passing freely up in that cavity, etc. So it provides basically no insulative value. And if you don't have any insulation in between your stud works, basically the only thing separating you from the outside of the house is your plasterboard, essentially, from the external. So I've heard it said that Australians live in glorified tents. Kind of holds true to some extent when you look at that brick veneer construction. So anyhow, brick veneer has a cavity in it. When we build with cavity masonry, obviously we also have a cavity in it. That cavity has to be between 35 and 65 millimetres. Can be reinforced or unreinforced. We reinforce when we do core filling of that cavity. But like our brick veneer, you have to have ties between the two leaves of brickwork as well at 600 centres, and also has to have weep holes in the bottom of that wall to allow for drainage.
Now, going back to that picture there with the mortar on that right-hand side, on the right.
This one?
Is that quite the norm?
So,
it looks shocking, actually.
Yeah, it does look shocking. What we can see here, this is the internal leaf of brickwork, and that's the external leaf of brickwork coming up on the outside. So they've built the internal leaf and the external leaf. Yes, that should not happen. Okay. Right? Bricklayers are required to remove those dags. The reason they're required to, I know. Yeah, what's in the code, what happens on site, doesn't always marry up. This is true. However, by the Australian standard, bricklayers are supposed to remove those dags.
Yeah, so that's unacceptable.
Technically, that's unacceptable. Yes, but
the reality is, though, if it's not an exposed face, what does it really matter?
The reason it matters is because those bits can fall off and fall away in the future, and they gather up down in the bottom of the cavity and they block up the weep holes.
Yeah,
That's the main.
Water as well. That's what gets me.
Yeah,
You know.
and that's the other thing. So it's about the way that the National Construction Code is structured and the way the legislation works is that you have performance requirements. So you have this performance requirement saying that moisture should not breach the cavity in brickwork, right? But then beyond that, it doesn't say how. Well, it does. It says if you do it as per the Australian standard 3700, then you're safe. It won't do it. You can get a bricklayer who can still have these dags on there, and then moisture doesn't breach the cavity. Essentially, they're still abiding by the code because they meet the performance requirements, right? Whether they should have confidence that they're always going to be meeting those performance requirements or not is another thing. And whether they're going to, whether they might have those dags falling off in the future and they get called back to do some rectification work because of moisture damage.
I wasn't too concerned because that's inside where the cavity is going to be. But it's going to be cavity filled somewhere. Who cares?
Yeah, and certainly when it's going to be cavity filled, well then the internal cavity, the core filling is going to breach the cavity anyhow, right? So for the purposes of that style of wall, it doesn't matter. But yeah, so that question really goes back to that nexus between how the National Construction Code works, how the legislation around this works, whether builders want to take on that, that liability, etc. Okay, yes, need good bonds between brickwork and mortar. That's fairly no-brainer. Another thing, tie down. So all buildings need to be tied down. Our roof typically is tied onto our wall frame. Our wall frame is tied into our floor slab. Our floor slab, by its weight and by its suction, is tied down into the ground. If you've got cavity masonry and you don't have a timber frame, how do you go tying your roof onto that masonry wall? Does anybody know? It's a tricky one, isn't it?
Yeah.
Some nails in.
Is that?
Put some nails.
You can put some nails in. You can put some dynabolts in. Problem with that is so you've got your pull-out factors, and so you can get for example your ramp. Now I'm not trying to spruik a product, but Ramset, they produce a really good catalogue of all of their masonry fixings. You can go, okay, an M10 bolt 75 millimeters long will have a pull-out, will restrain 1.5 kilonewtons of pull-out force. So you can do that. You can say, okay, these are the kilonewtons, and you do that. That's one way of doing it. One problem with that is, though, that if you look in that catalogue, it'll say you need 75 millimeters edge distance between your fixing. So edge distance is the distance between our wall here, like this, and we've got our dynabolt in there, like that. Our edge distance is this distance in here, and that distance in there. If it says we need 75 millimeters edge distance, there's no way that we get that with 110 brick right in the centre. At best we get 45 millimeters edge distance. So that's an important thing to look at, because if that all went pear-shaped and you called into court and they go, well, the product manufacturer specifications say you need 75 millimeters edge distance for your masonry fixings, that doesn't float. But certainly there are plenty of fixings that require less than have lower edge distances. Just be aware of it.
Okay.
Another
with the timber stud wall, are they bolted down to the slab?
Yes.
Yeah.
Yep.
So basically, if you tie in the trusses to the stud walls, everything should basically stay together.
Yes. Yeah.
So to me, it looks like the brick walls must probably be the weakest part of any house.
Well, the brick wall is just a cladding. Yeah, and that's of course. Yeah, it is. The brick walls have some sort of structure to them, and they have a resistance to them. They, a child on a bicycle that hits a brick veneer wall will probably not move the brick veneer wall. And the brick veneer wall, after that impact has happened, you would probably not know it. Whereas if that same child hit a rendered blueboard wall, the bike might, break through that wall. So there's more structure to a brick veneer cladding than there is to some of the lightweight fibre cement sheet claddings. But still, it is just a veneer, and it is not relied upon for the structure. But tie downs, the other way that we get our tie downs to happen, let's see if this pen is a bit better, is when we've got, oh that's fantastic, when we've got cavity masonry like this, our 2 layers of brickwork like that, and we've got our rafters heading over the top, want to tie that down. One thing we can do is, and it can be done, so typically it's done as the wall is getting built, but you can do it retrospectively as well. The way you do it retrospectively is drill, 10mm drill or 10.5mm drill through these mortar joints here and slot in a 10mm rod. Then galvanise iron strap, loop it over, tension it, nail it. Binds it down to your brickwork. That is a very solid way of doing it. The Australian standard sets it out at 900 deep into the wall, but you can also, like we used to specify it at 1200 for some situations. So that's another way of tying down a roof frame into the walls. So for N1 and N2, oh look, these actually these figures probably shouldn't be in here because, well, yes, rafters at 1200 centres. When you've got a sheet roof, your rafters are at 1200 centres anyhow, and your fixings happen at 1200 centres. But your wind loads are dependent on the amount of roof that's acting upon those rafters. So these things can be varied. So yeah, here's a tie down strap detail for that one there. So the wall ties, these things provide the strength in a wall. They must be protected from corrosion as per AS 3700. Connects 2 leaves of masonry or masonry and timber or metal stud. Acts to stabilise the masonry leaves and stiffens the wall cavity structure. I worked on detailing the repairs of a building in Norwood that had a big Besser block wall of warehouse. That whole Besser block wall fell over and fell onto neighbouring buildings. It did that because of the wall ties. What the builder had done is welded wall ties onto universal beams. So big, thick universal beams with a tiny little wall tie. That's a very hard weld to make. Just to think about it, 2 or 3 millimeter steel, 3 millimeter steel, 3 mil, welding 3 mil onto 12 mil, universal beam. That's a very hard weld to make, even if they did that properly. But all those joints just rusted out in no time. So that Besser block wall ended up having nothing to restrain it. It was just a Besser block wall standing there. So get a bit of wind behind it.
Check some of my stuff then.
Maybe that was one of yours. Yeah. So yeah, I would not want to be the builder who did that. I'd not want to be the person who specified that, who said, "Oh, you just weld your wall ties into the universal beams." Because these once you weld something, you open it up to corrosion. You heat it up, it corrodes with steel. It corrodes really well. Those wall ties have to be protected from corrosion. Also embedded 50 millimeters into the mortar joint to ensure that they're locking into that masonry. Must have 15 millimeters of cover to any surface to ensure that they're not kept in a wet environment. Should be installed to prevent moisture breaching the cavity. I'll pass this guy around. You'll notice some little dimples on here. Those dimples have to face down. The reason those dimples have to face down is because they're drip grooves. They cause water that's coming down the cavity to hit that wall tie and hit that little groove and drip down in the centre of the cavity. And here's an extract from AS 3700 explaining the spacing of wall ties. So you look at this, yes, there do need to be a lot of wall ties in a wall. Yeah, ooh. So at 600 centres for most of your wall, but then at 300 centres around your openings, and at 300 centres either side of an articulation joint. To comply with the requirements for insulation under the National Construction Code, you need to have some insulation, R1.5 for many areas. To achieve that, there are various different thin PIR foam insulation products, so it's not as cheap as your bats, but you can also install that insulation in your cavities as well to provide that insulative value. While we're on it, it's something that's not really touched upon in the slides, but is everybody familiar or has heard about reverse brick veneer? No? Right. So brick veneer is where we've got a timber frame, bricks on the outside. Reverse brick veneer, yeah. Timber frame on the outside, bricks on the inside. Basically, that means you've got to clad your timber frame in something else.
Only a bricklayer would do that.
Yeah. So, yeah.
It's actually gaining popularity.
It is certainly gaining popularity, and started off being called reverse brick veneer because it's about, doing that internal leak with bricks. But there are many things now where you've got some form of plastic formwork that you can fill with concrete that provides your thermal mass on the inside of your walls. Basically, it's just about bringing thermal mass inside your house. Everybody understands the use of thermal mass here, do they? Yeah, we've got.
They probably don't.
What's that?
So they probably don't if you really ask what thermal mass does.
Okay, well, who do I want to pick on? Ina, do you want to tell me about the use of thermal mass?
Thermal mass is a material we use in the building and it can keep the energy passing during the time. Look like a different wood, different material of the monsory. Anything.
Yeah, that's fairly good. Fairly good.
See, the thing is,
Does anybody want to add to that?
it was non-existent when our house was built because our walls have got no insulation.
Oh, I don't know about that. I think people have understood the concept of thermal mass for thousands of years.
Yeah, I think they have, but they just haven't used it.
Oh, yeah.
Very wrong. Iranians have been using thermal mass
Exactly. Like you visit,
for
yeah,
thousands of years.
Yeah.
I mean, probably.
yeah, Yazd
They're
or
probably the leaders.
Yeah.
If anything, of using thermal mass and natural.
passive air conditioning.
When you look at how many of our houses, like the one we demolished, didn't have any insulation in the roof at all.
Mm.
And for thousands of years we've known about it, but we've never done anything about it.
Yeah, so it's about reliance on other things, etc. Okay, Australia has a very funny architectural history in that we had a lot of people come predominantly from Europe and go, all right, this is how you build a house. We'll build a house like this, and that house didn't really work, and there wasn't a huge amount of thought.
Yeah. Oh, those.
Yeah.
Yeah.
Okay. I'll bring up some images. So that's in Yazd, is it? Or
Yes.
yeah.
Can you actually feel the air moving through it? Because it's such a huge. You have to be able to go there and experience it.
Oh, yeah. It's quite amazing.
Oh, maybe the next one. Yeah. Down with the USA. All right, maybe the next one. Okay. So, yeah. Some. This is not only about thermal mass. In a way, it is about thermal mass. What's happening here in this picture is that these towers adjacent to these buildings, or they're part of the building, will take in air from the windward side, drive it down underneath the house. Then there's like a cavity, or sometimes even water storage under the house, and then there's mesh, or how to say it, grated sections in the floor, where that air that's being driven down under the house can come up inside the house. And because it goes under the house, it uses the thermal mass of the earth, that cool earth, to cool the air as the air passes down under the house. Then it comes up through the grate, and because warm air rises, cool air sinks. That cooler air comes into the room, displaces some of the air, which is the warm air, which has risen to the top of the room. And on the leeward side of these cooling towers, that warm air is sucked out from the roof space, from that ceiling space. So in one way, it's a passive form of evaporative cooling, because it uses some evaporation of moisture as well in the earth or water that's stored under the house. Because it only takes a very slight breeze to create that, because it's predominantly assisted by that hot air rise and cool air sinking phenomena. So it's a passive form of air conditioning, but it also uses the thermal mass. And we can do that. We can do that here in South Australia. It's, South Australia is a fantastic place for it if we
That's
so
what got
design.
me, because I've seen it on TV, on the documentary, because the amount of water they've got going underneath the ground, and I'm sort of thinking, oh, well, out in our desert we've got the artesian bores from streams to underground streams. We should be building buildings like that in the outback.
Yeah.
Instead we just put a veranda around it.
Yeah, but has anybody been to Cooper Pedy? I guess this isn't happening in Cooper Pedy, right?
No.
Well, not that I know of. Maybe it is.
No.
No. All right. But but still, you've got people living underground in Cooper Pedy, digging holes, and that's using the thermal mass of the ground. So typically, when you dig down far enough, the ground temperature is at that stable 19 degrees.
So
it's not too bad.
Kind of geometric energy. So
Oh.
pipe with the ground and then using the.
Yes, and that's not so. You mentioned the artesian basin. Now, artesian water comes up about 98 degrees. When you sink a bore and hit the artesian base and bring it out, it's coming out almost boiling. So it's pretty hot. Yeah, Dalhousie Springs. Yeah. But places like Iceland, they're using that. They sink a bore, they bring out that hot water, and because it's at 98 degrees or whatever, I don't know what temperature it is when it comes out of the ground there. Because it's really hot already, they just add a little bit of energy to it, and then it makes steam to run turbines to produce electricity to do aluminium smelting. They do aluminium smelting in Iceland. They don't even have bauxite in Iceland. They bring it all in there, but they use it for free energy. But I think we're digressing a lot away from masonry about all that. But yeah, all very incredibly interesting. But yeah, so here we've got mud brick masonry buildings. So it's using that thermal mass of the earth. Typically, these buildings are also built to be used seasonally. Am I getting that right? That built around a courtyard and uses the sun at various different times of the year, and people will change their use of that building throughout the year to go, well, this time of the year it's really good to be sitting here. Later in the year, it's probably good to be sitting there. And so the buildings are sort of flexible in their use as well. So that's
And other thing I found there was they call the shower of the Sheikh Bahai, and they just warm the water with the one candle, just the one candle.
right.
And was in the kashan, this is the shower.
Yeah.
As was looked like a public shower, the people can see each other.
Yeah.
But
Yeah.
they could keep the hot water with the one candle.
One candle for their hot water system. Yeah, yeah. That's yeah. Yeah,
This is
I
the
might,
tradition of-
yeah.
So,
So
how old was this system? You know,
No, in the 3 or 4,000 years ago.
we'll
yeah.
catch up.
Yeah,
We'll catch
yeah,
up.
but it's when you can rely on abundant energy, yeah. Anyhow, so but we can get thermal mass into our buildings. Great way of doing that is a concrete slab on the ground. That concrete slab that we build our house on, sun shines on that concrete slab during the day if your house is oriented correctly. That concrete slab soaks up all that heat from the sun and then overnight gives that heat out into the room. And so it creates a thermal flywheel. Another way of doing that is to build with, rammed earth, spine wall through your house, or reverse brick veneer on the inside of your walls, etc. Bring heavy materials into your house that will soak up that heat when it's hot and give that heat out when it's cold. That can work very poorly if it's not done correctly. I live in a very old cottage that is an absolute shocker after about 4 or 5 days of hot weather. The whole house heats up, and that's it. You're stuck with it.
It's beautiful
yeah.
when you get a cold snap a few days later and you're nice and warm.
Yes. So thermal mass is fantastic for creating that flywheel. You have to understand that it has to be used correctly.
Sustainable panels.
Yes, yeah, and the concept of building in a sustainable fashion. It's about just building comfortable houses that keep themselves comfortable themselves, without requiring a great deal of input of energy into them, and that comes around design. Now, it's not the only factor of design that we have to think about. If we were to go, have this blinkered view about, okay, we build sustainably, we only do everything to the nth degree of making it energy efficient, then we sacrifice things like views and functionality and connection to the street and aesthetics and all that sort of stuff. We can't look at it in isolation, but we can often look at it as an initial thing in planning and go, this is how we're going to ensure this house is going to be comfortable and maintain its comfort without too much input of energy from the occupants. Now, so back to brickwork. Essentially brickwork, not hugely environmentally friendly, has a lot of embodied energy. All the bricks are fired clay, so they're fired in the kiln, uses a lot of electricity or coal to do that. But our brickwork, because it's a very rigid thing and our soils expand and contract, here we get cracking in brickwork. With raft slabs, that has significantly been diminished because we've got slabs now that are designed to just float around on that moving soil and carry the weight of brickwork. But also we need to build in articulation joints. So those articulation joints need to be beside a window when we've got an opening of greater than 900 by 900, and it depends on the type of soil, at every 5 metres interval or every 6 metres interval, depending on the type of soil.
What actually expands in the masonry? Is it the mortar joints or the bricks or both?
Well, every single piece of any material you get expands and contracts with heat. So you heat up, like steel is a great one, you heat up a piece of steel, it expands, cool it down, it contracts. Bricks do the same, concrete does the same. So everything in that brick wall will expand and contract. So there's some expansion and contraction from that. It also expands and contracts very slightly, both the brickwork and the mortar, from the uptake of moisture. But beyond that, it's not just about expansion and contraction. Your joints in a brick wall are called brick control joints. That allows for expansion and contraction and articulation. So you've got your brick wall doing this, that's the articulation, the moving. That brick control joint allows for both that articulation and the expansion and contraction. So those brick control joints So as I said, well, here for more reactive sites, 5 metres max, and for stable sites, 6 metres max. You need to have an articulation joint when you've got a change in wall height, and you need to have an articulation joint when you're joining a masonry fence onto a building, or where you've got a sizable opening, such as a door or a window. So refer to AS 3700 for the location of your brick control joints. It is super important if you are drawing up a brick veneer dwelling that you specify where brick control joints go, or at the very minimum, you say all brick control joints to be installed as per AS 3700. If you don't, you'd be very unlucky, but you may get a pedantic bricklayer who goes, well, they didn't specify any brick control joints in this, I'm not putting any brick control joints in, and then it goes to pot because of that. So either at least understand thoroughly the location of brick control joints, or specify them as per AS 3700. Fill material mastic is not to impede the movement of the joint, and those joints are not to be toothed into another masonry wall. So those joints have to be able to, those joints are clear and they have to be able to move freely. The way those joints are constructed is, well, there's several ways. One is to use a backing rod like this, a closed cell foam backing rod that is squeezed into that 10mm joint, and then you've got some mastic on the front of it, mastic like silicone, spongy, rubbery filler. Another way of filling in that control joint is with a piece of this stuff, which is the same sort of stuff as the lagging around pipes. Once again, closed cell foam.
I noticed that they still put that control joint in between tilt-up concrete.
Yep.
And it doesn't ever seem to sort of move though.
Well, ideally it shouldn't, right? But you've got to allow it to. That's the thing. That's the thing about control joints. Yes, if you can design things to resist all of the flexing pressures that our unstable soil imposes upon buildings, if you can design against that and have no visible movement in a building, that's fantastic. That's the best case scenario. Second best case scenario is if you can confine any of that movement to the places where you want that movement or will accept that movement to happen. That's what the control joints are about. So at every 5 metres or every 6 metres, it just means that you get that movement happening in that control joint, not just in the middle of your brick wall and it looking horrendous. And same thing with your tilt-up concrete slab. You want that movement to happen between your joints.
Tilt-up concrete in those big buildings.
Yeah.
And you're saying, they've got a control joint there, and that might be 10mm, 15mm
Yep.
between them. Okay. And those things move. Okay. If you were, I'm going off tangent.
Yeah.
If you, so I only had this conversation Tuesday with an engineer. If you're then taking some of the cement away, exposing some of the rear that's in there.
Yeah.
Okay. Then tying that together, and obviously, how I'm having that float slab put on top.
Mm-hmm.
I'm taking away all that expansion, aren't I?
Yeah, if you're tying into both those. Yeah. So.
And I was trying to think about that because we were discussing the profile of it, and I said, what happens when those exterior ones that will heat up and contract a lot quicker than the interior ones, because they're obviously going to have the same exposure?
Yeah. So you're right. You may have some differential movement that happens there, and you may have some separation of joints that happen there as a result. Typically, what should always be done with control, and this is a way of looking at control joints in everything, not just masonry, but control joints should always be carried through a building. So we might have a control, if we've got a control joint in a floor slab, and typically with a raft slab, you don't have any control joints. A raft slab is designed to work like a raft. There are different types of slabs. There are, and the slabs here, if you walk around Tonsley, you'll see saw cuts in these slabs. These are not designed as raft slabs. Right, so you've got concrete slabs. If you've got a control joint in your concrete slab, you should also then have some form of control joint or some acceptance for that movement that's going to happen in your control joint in your slab to happen in your wall. You should also have accommodation then for that to happen in your roof. It should happen vertically all the way through a building.
So even if you're piling over the top of it, for instance, like you'd even have where that control joint is, you'd have your
silicon bead
mortar joint, or
definitely. If you've got a control joint in some form of solid walling, and then you're tiling over that, yes, you should have a control joint in your tiling at that point with a silicon bead in there and probably taping behind it to ensure that it's not.
Well, we even take that to
not
another extreme. What about glass? Because if you tie in glass isn't going to move.
No, glass isn't going to move. We don't have any. Oh yes, we do. We've got a double mullion. Got double mullions here.
Yep.
So, okay, that can be a control joint. If we go straight through our window frame down there, we have a joint in our window frame. That we can carry that above a control joint in our floor slab to enable that frame to do a little bit of movement, and we can have some flexible packing between those mullions to enable that. Yes, you don't want to have your pane of glass, centre over the control joint and things like this happening with your frame.
Sometimes use the cable, the cotton one or the cable.
Okay, yeah.
Cotton, every cotton have a cable, jointed kind of cable.
Yeah. What was that? The first word? Every
Cotton.
cotton.
They use the glass.
Yeah.
For the facade.
Yes.
Cotton,
yes.
Cotton. How to pronounce it?
Cotton.
C-U-R-T-A.
Oh, curtain wall. Curtain wall. All right. Yeah. Sorry. Oh, yes.
Oh.
Okay. Yes. Curtain wall glazing.
Sorry.
Curtain wall glazing. How to say it? Yeah. It's a different animal. Once again, yes. Many factors to think about with the expansion and contraction and movement in curtain wall glazing. But yes, you have to enable for that. For any control joints you've got happening in your slab, for that to happen in your curtain wall glazing as well.
With the cables.
Yes. Yeah.
Making more flexible.
Yes. So a fantastic example of that is in the convention centre on North Terrace. Got their great big what are the horizontal elements called? I can't remember. Is it transoms? Transoms? Yeah, transoms supported by cables that run up and down. So rather than have mullions to do that job, cables to do that as well. Yeah. So these control joints, they have to be carried through every element. Look, Doug, with your place, it may be different. It all depends on the footings and what those footings are designed for, and whether those joints in your panels are actually designed as control joints or not.
It's up on. That's all suspended on that steel. So it's like I actually went and saw an engineer because of crazy things that were happening. And I went, okay, so I've got to get a new engineer. And it was sort of like, here's an area of identification that the builder and I have sort of called out. And and I've said, look, I think there's going to be more. So I wanted to sort of say, okay, what do you do here? Because we can see a potential problem there. And there's a few others as well. So just so we've got an engineering.
Yeah. And it's all very, very complex.
So these control joints, will they work for expansion and fast movement as well? Like, if you have an earthquake, that will it work?
So not designed for earthquakes.
Earthquakes.
What's that?
I say he's obsessed with earthquakes.
Yeah.
We don't have
So
earthquakes.
So not designed for earthquakes. So designed to enable the articulation brickwork that we require for our reactive soils primarily. That's the main consideration.
So what gets me is, you know, if you've ever been to IKEA and had lunch there, you can actually feel that slab moving. You know, and I don't know why it moves. You know, it's the same thing if you're in a building that's got a above ground car park. You know, you can sort of sit there and you can feel the floor move. You know, does that do the control joints work on that?
Well, certainly, certainly they do take up some of that. Typically, you know, your buildings are not designed to have that great deal of flexibility. But when we're talking about commercial construction, that's many more considerations in all of that, and it's probably a bit too much. That question that's a very big question. Probably a bit too big for this lesson. But yeah. But just for our standard residential, talking about brickwork, those control joints, so brick control joints, BCJs, also known as ARJs, articulation joints, but it's always good to denote them as BCJs. The BCJ includes an articulation joint and an expansion and contraction joint. So they have to be spaced around the house. Of course, they have to be spaced as per our brickwork dimensioning, and they have to be spaced every 5 or 6 metres. So when we've got these long runs of brickwork in our garage, we have to have that articulation joint happening in there. Covered all that fairly well. So yeah, here's some details about how those articulation joints form. So they have to be sealed up, and you have to have ties of your brickwork across those. So ties that don't stop it from moving, by the way. So I mentioned those cavities have to be free. Well, they do have to be free to move, but that brickwork has to be tied together with other brickwork as well. So you've got these sliding ties. I've got one in here somewhere, but we can see them here. These ties that enable that movement in and out. Also, for concrete block work, I mentioned that house for the final progress inspection that used concrete bricks and you know, cementitious mortar, which all shrank over the week as it went off. One way of controlling that shrinkage is to use ladder mesh in your concrete block work. If you're doing concrete block work that has to control that shrinkage, and you're doing long runs of it, then ladder mesh disperses that shrinkage throughout the wall. Also, very important with any form of masonry is the dealing of moisture. So moisture probably causes the most problems in buildings. You have to have can't think of the word right now. Not a vapor-proof membrane.
Mastic.
What's that?
Mastic.
No, not mastic. So this. Oh, gee. Yeah, strangely enough, I forget the word. Okay. Oh, damp-proof course. Okay, it's written up here. So you have to have a damp-proof course under at least your lowest layer of masonry. That damp-proof course stops moisture coming through any of your footings into your brickwork. Before the days of damp-proof courses, we had salt damp. We still do get salt damp in modern buildings in very rare occasions if that damp-proof course isn't put in correctly. Or I've even seen it on a complete building not put in as well in a section.
Did they rely on the lime in the mortar to act as a damp course in the old days?
Oh, there's a whole host of ways of doing it. One way was with clinker bricks. I think I might even have a clinker brick in here. Clinker bricks, bricks which are double fired. So they get fired and they get fired again, makes them really hard. They transmit less moisture. So you'll see plenty of buildings like 1960s cream brickers with a layer of dark bricks around the bottom. Has anybody seen those houses? They're clinker bricks to stop that transgression of that progression of moisture. Another way of doing it is with
bitumen in your mortar at your low level. So there's this bitumen layer to stop moisture coming through. The other ways of dealing with it was good subfloor ventilation. So many houses were built with strip footings and cavities underneath their floors, and those cavities are ventilated and enable that moisture to get out from under the house, so you don't get as much moisture transferring into your walls. But today, basically the standard is damp-proof course, and that damp-proof course is also typically carried up and attached to your timber frame, so it works as a flashing on the base of your wall as well. So as moisture makes its way down inside that cavity, it hits that flashing at the bottom and it gets carried out. So this polythene film does both of those things: damp-proof course and as a flashing at the base. Incredibly important that it's installed. Yeah, if it doesn't get installed, get stuff like this happening. So that's where we've got moisture coming into masonry. So moisture, yeah, incredibly destructive in buildings, but it's also incredibly unhealthy. So very unhealthy thing to have mould growing in your houses. So, yeah, moisture can penetrate through external walls of the cavity and down inside face of wall. We accept that. Cavity must be clean and have uninterrupted damp-proof course and flashings over doors and windows. Excess dags or snots must be removed. That relates to that brickwork that we were talking about before. Yeah. Excess mortar can fall down the cavity and bridge the damp-proof course. Need to keep cavity clear during wall construction by cavity batten board, leaving every fifth brick out, etc.
See, I don't think we hear of damp in modern day buildings anymore.
No, because largely
it doesn't exist.
No, it does. But largely it exists now because of errors in bathrooms and the way waterproofing has been done or hasn't been done in bathrooms, mostly around tap fittings in showers and breaches. So where you've got your pipe that comes into and you split your hot and cold. Yeah, well it's issues with plumbing, it's issues with waterproofing around that particular plumbing junction. There was also a spate of issues with moisture in buildings when steel frames were first introduced as well, because you had people running plumbing pipes in the steel frame. They go, oh, this C-section, that's a lovely place for running a water pipe. And then the gyprockers come along and they go zip, 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 and install their gyprock. And you had these screws going into pipes. Now that PEX pipe, you can put a screw into that and it won't leak. Today. And then 5 years down the track, you get this moisture coming out in your wall. Like, what's that from? That screw has rusted away, and then So there are still
I noticed
plenty of moisture issues that happen in houses for different reasons.
A twin solid brick house with a solid plaster. Now with a copper pipe, sort of just built into sort of the brick that's just been sort of chiselled out.
Yes.
And all of a sudden it develops a leak, and so it's amazing how far that dampness travels. That plaster actually like a sponge.
Yep. Yeah. So yes, certainly with modern building construction and design, we've gotten away from many of the issues that relate as a result of moisture, but not entirely. Actually, good segue, flashings are also a common point of failure. So flashings, and this is probably really good stuff to talk to people about, talk to Revolution Roofing about as well. Before next week, go on, have a look at their stuff, have a good look at and think about flashings. And you can ask them some curly questions about making up various different types of flashings, because they're fantastic there at making up flashings for all sorts of things. But yeah, that might be a good thing if you want to have some questions to talk about flashings. Yeah, they're the people to ask about that. But flashings are typically pieces of metal, but but it doesn't necessarily have to be sheet metal. It can be, you know, that polyethylene or polythene, or it can be sometime aluminium and bitumen composites, all sorts of materials act as flashings. Flashings are bits of sheet material of some form that direct moisture from one place to another. So typically, you know, from where it is to where we want it without going where we don't want it. That's, you know, yeah. And so flashings are installed for all sorts of reasons. Here we've got this flashing on the edge of this roof, cut back up into brickwork to ensure that all the moisture coming down here goes onto the roof and not into the wall. Flashing here, right at the base of this sheeting, to ensure that any moisture that gets behind the sheeting goes out, and any moisture coming down the face of that sheeting goes away from the building. Here's a detail about parapet flashing. So parapets, that's where you have a wall that continues past your roof. Where you've got that wall continuing past your roof, obviously you have a great, that's a very susceptible place just there. You want to ensure that any moisture, any rain coming in on an angle like this, it hits this wall, is going to go onto that roof sheeting and not down this gap into your house. The way that's done is with a two-piece flashing. One piece of flashing goes onto the sheeting and bends up. The next piece of flashing is built into the brickwork and then bent down over it. This doesn't have to be waterproof. This isn't going to be a swimming pool. You know, if it was, then water would just pour through here, right? But it's not about being waterproof. It's about directing moisture to where we want it. So water goes, you know, gravity. Wake up every day, you've got gravity. That makes moisture go downhill. Several different ways of doing it. One way is to have carry that flashing across the cavity and have a weep hole at the front of the wall. Probably a much better detail is where you carry that flashing across the cavity, have your weep hole facing back towards your roof. Because with this, you know, when you get moisture, you get molds and lichens and things like that growing. You don't want that happening on the front of your building. Also, openings in masonry for your doors and windows. We can't just start building masonry in thin air. We need something to support that. So we need something to support it while we're building it, but we also need something to support it over its life as well. That's done by things like this, these steel lintels that go in there. Pass that around. So actually, I'll just quickly, before it goes around, I'll just quickly show how the brick sits. Sorry, yeah. So that faces out like that toward the front of your house, and then you've got the brickwork that goes on top of it. So you just end up seeing a small little piece of steel. That's the way it's installed. As a designer, you specify your size of lintels as per the size of openings. So as the openings get really big, you need much stronger lintels to span that distance. As the openings get really small, you can get away with much smaller lintels. So there's a common manufacturer of these lintels, Prida. They have their design, their product literature for designers. It says, okay, you've got this space to span with this much brickwork over top, you can use this one.
Is there a set distance where you need a lintel like is it at 1800 or is it 3 metres opening or?
You need a lintel in your brickwork over any opening.
Any opening?
Yeah, over any opening. Oh look, actually, so if we've got a 200 wide opening or something, and we've got two bricks joining above that are only cantilevering out halfway, maybe we don't need a lintel.
Toilet window, you know,
what's that?
Even a toilet window?
Yeah, because if you've got a brick that is not sharing any form of support anywhere, is relying purely on suction of the mortar to stay there, I don't know that I'd like to rely on that.
The window's going to hold it up.
Yeah, glass is awesome for doing that, isn't it? Right. So you need to install lintels in your brickwork to ensure that the bricks don't fall down. Minimum bearing areas for lintels over openings, typically 100 millimetres. either side, or 150 millimetres for large spans. So here's several other different types of lintels for spanning larger distances. And here is a whole series of lintels on site for ready to go into a brick wall. And I think that's from AS3700 as well, an extract from that. But, you know, so, you know, 90 by 90 by 6 E. Does anybody, okay, 10 points for anybody who can tell me what a 90 by 90 by 6 EA is? EA, does anybody know what EA would mean in that context?
Equal angle.
Equal angle, yes, so 10 points to be used at a later date. Right, so we've got our equal angle. That means it's 90 millimetres high by 90 millimetres wide by 6 millimetres thick. So how thick is that one? 4 mil? 5 mil?
Yeah, 5 mil.
5 mil. So 90 by 90 by 6 equal angle is actually very similar to that, but slightly thicker. So that's our EA. So and sometimes, you know, when I was doing drawings for engineers, I would have them, you know, they'd write 96 EA, like, you know, or, you know, 96 EA, that sort of thing, because you don't need to tell me that it's 90 by 90 because you've already told me it's an equal angle. So can anybody think of what UA is? We've got a 150 by 90 by 8. Yeah.
It's unequal.
Unequal. Yeah. Yeah. So you've got equals and unequal angles, and then you've got your various different I-beams, etc. And that's it for masonry. And 3 minutes left for any questions regarding masonry. Okay, so just quickly, has anybody managed to be on site yet and get stuck into a site visit report?
What do we actually look at on the site?
Right. Okay. Well, that is all defined in, and that would take us a very long time to go through.
Yeah.
But if I close this down and we open up assessment task site visit report. Taking a while. Okay. We can choose to look at footings. We can choose to look at timber wall framing, etc., etc. So, you know, let's say we were to look at that timber frame that's going up down the end of the Alawuna Avenue as you come in there, the one with lots of OSB bracing all over it. Before we go to look at it, we want to go, all right, well, what I'm going to need to know is what the wall frame timber species is. You know, I'm going to have a look for, you know, stamps on the timber to say whether it's cypress, whether it's Pinus radiata or something else. What the lintel materials are, is it solid sawn timber, is it LVLs? So I'm looking at that. Looking at the member sizes, so uprights would be 90 by 45, top plates 90 by 45, etc. Lintels, various different sizes. So what our common studs are, what our bottom plates are, top plates, lintels, noggins. If I didn't know what any of those were before going on site, I'd definitely make sure I knew before I was going on site. Look, you can take plenty of photographs, but you can't remeasure stuff. Yeah. So take a tape measure, and also you can, you know, take a tape measure and take photographs. Size of studs at size of openings, at sides of openings. So I definitely want to know what studs are before I went there.
So basically, we're going to a building site where roof is on, frames up, slabs down, but that's about it.
No, well, so the thing is, you don't have, so you choose one of these. So you could choose to do footings, for example. You could choose your, I don't know if you took photographs when they did the pour and all that sort of stuff. You know, you probably know all that information about your footings. So you can say, all right, I'm doing the footings one. putting my photographs, putting information on that. And if anybody sees a site whereby there's, they've compacted the site, they've spread their dolomite, and they've got an excavator digging out trenches, it's probably a really good time to go, hey, can I go on here, take some photographs, etc. I'm from TAFE doing this, I'm studying this, I'm doing footings report. Take some photographs at that stage, and then pop back a couple of days later, you'll see that they've got the orange plastic down and the trench and the mesh in, etc. Go take some more photographs, and then ask them when's the concrete pour happening. Come back when they're doing the concrete pour, take some photographs. That'd be fantastic as well. So yes, footings is a little bit harder to do that because you've got several visits because it happens over several times. But yeah, you were there for yours. Do yours. So you do footings, timber wall framing, steel framing. If you see steel frames going up, you can do exactly the same for steel framing as you can for timber wall framing. Suspended upper floors. If you see a 2-story place going up, you could decide to do the suspended upper floor. Trussed roof. If you see a trussed roof going on, you can decide for that.
So we don't have to do it on all, because I thought we were going to be doing it on all of those.
No, choose
Just
one.
one.
Choose one. So So mostly it's about finding a site you can get onto. If you can get onto a site, then you can choose your site visit as per the site you can get onto. Yeah, well there you go. So whatever stage you're at, whatever's easy for you to document. What's that?
They did all the metal work for before they were going to lay the cement today.
Yeah.
But the engineer came today and said, no, this is done completely wrong because you can move the whole entire thing. Like you just put your foot down and the whole entire thing moves.
Yeah.
And it's like bowed like this. So
It's incorrect supported.
Not very good.
And so all that, how you meant to do all that, that's all detailed in AS 3500 concrete structures. How that's meant to happen. Your engineer probably came on site and go, you don't have proper laps of your bars. It's incorrect.
We were trying to get in contact with the builder, but he wouldn't come. So my granddad was just like, well, I'm just gonna get an engineer down there.
Yeah.
And he came down because he was like, this isn't right, because it wasn't right.
Yeah.
It was done really bad. You could tell it's like bowed in the middle. Like it was just, and then like far left is like in the ground pretty much. It's kind of like. So,
When you get home, you better take some photos.
Do the footings on if you wish. But yes, super important to get all that steel work right because you can't rectify it once the concrete's gone down. But you can, if you see a place where the brickwork is done or being done, do a brickwork site visit or linings and second fixing. So choose whichever one you want. Linings and second fixing probably a little bit harder to get on the site because the buildings are all closed up at that point in time. But yeah, choose one. Choose one of these. Mostly it's about trying to get onto a site. I'll try to get us onto a site anyhow, but please don't rely on me getting a site within 2 weeks that I can take a whole group onto. Try do it independently. But what you don't have to have any permission for or any organisation by any other person to do is your research assignment. That's completely on you and your time, etc. So get stuck into that one. Get it out of the way. Much of what's in there has been covered so far, so you can work on a fair chunk of that already. And what's not already covered, you can research as well. Does this mean it didn't record? No, it's recording. Must be recording somewhere.